Okay, hello everyone, and welcome to this talk. So I want to start out with a little question. So imagine you would have to write a small command line application, and you would have to parse a command line parameter in this application. Who of you would go ahead and pull in a third-party dependency to do the job? Okay, it's some hands, not everyone who wouldn't do it. So I guess it depends. So how about now if you want to parse a JSON file, maybe something a bit more complicated? Would you pull in third-party dependency? Yeah, everyone. And how about in Python? Would you be more inclined to use third-party dependencies than in C++? Raise your hand. Okay, so the thing is that nobody really wants to reinvent the wheel. And we know that we can reuse existing functionality. But using third-party functionality also comes at a cost. And for C++, that cost is extremely high compared to other programming languages. However, there's ways how we can handle C++ dependencies, and we do have C++ dependency managers. So therefore, in this talk today, I would like to take a look at the fundamentals of dependency management. I want to take a look at how other programming languages do it, how we do it today in C++, and how we can potentially improve it in the future. So, what's my motivation to give this talk? My name is Kerstin Keller, and I'm a software developer at Aumovio, which is formerly known as Continental. We're an automotive company, and we make sensors and software for automotive. I've practically worked all of my professional career at Continental, and 10 years ago, I had the chance to move to a new department, the pre-development department, where we are working on autonomous driving. So 10 years ago, autonomous driving, it was really like the thing. Everyone was working on it, and I had the chance to be part of it. So we had cars, like regular cars. We equipped them with extra sensors, very powerful hardware in the trunks of the car, and ran our stack on them. These were Windows PCs. But yeah, that was 10 years ago. So at the first day in this new department, I'm explaining like how does everything work, where's the sources, and so on. So I go ahead and I clone the driving stack. And it takes quite some time. And I'm wondering. I take a look, and now there's 40 gigabytes of data on my disk. So I'm thinking, okay, before I worked in series, like the project is like really small, not so much, but here I have 40 gigabytes on my disk. So what's going on? I look throughout the repository, and I find them. They're everywhere. So there's Boost DLL, OpenCV DLL, Glue DLL, WXWidgets DLL, you name it, they're all there, and they're scattered all throughout the project. So I'm thinking to myself, like, okay, that can't be right. Like, why is it like this? So I've had some prior experience with Python, where we have pip, and I've had some prior experience with C#, where there was NuGet. So I was thinking, okay, surely there's a solution for C++, so I'll just go ahead and find how we can do it. And boy, could I have been more wrong. So I go and I search, and I find practically not a whole lot. So I do go ahead and take out all these dependencies, move them into a separate folder, so at least when you multiple times clone the repository, you only have that on your disk just once. But still, it's not a good solution, because back then, we were on Visual Studio 2012. We wanted to move to 2015, and we didn't know where do these DLLs come from, who had compiled them, how do we recreate them, because there is no ABI compatibility between Visual Studio 2012 and 15. And actually, it took one of my colleagues half a year until we could make that change. So that's a huge cost, actually. So I kind of, like, over time, we also wanted to switch from Windows to Linux, and we had the same thing. So I kind of made it my quest to find a good way to handle this. So time after time, I was looking and seeing if there's any new possibilities, anything we can just do. So there was Hunter, there was vcode, there's also vcpkg, but they didn't quite fit our needs, what we wanted. And then at some point in time, I did find Conan. And that was the first time when I thought, okay, this looks promising for us. Let's see what this is about. And at this point, I want to take a little time just to thank the Conan team for the amazing work that they've done for the C++ community. I really annoyed them. So over the time of the years, I opened 37 questions on their GitHub issue. And it actually, so the first time I found it was maybe late 2017, but it took us 3 or 4 more years to actually make that switch to go and build on Conan. So before we want to talk about dependencies today, let's quickly define what is a dependency. So I did go ahead and ask ChatGPT to give me a definition of a dependency, and he comes up with a software dependency is any external software component, such as a library, framework, module, service, or package, that given software system requires in order to compile, run, or operate correctly. And what is also really important to understand is that you have a dependency that has its own and independent release cycle of your software. So if this is something which you just have as part of your own code, then it's not necessarily a dependency because you manage the releases together, basically. But in the sense of this talk, a dependency is something which really comes from external and has its own release cycle. So let's take a look, really, what is dependency management, or what do we understand as dependency management? So for this presentation, we will take a look at a small program which has some dependencies which form a dependency graph. So we will have a command line application which is a monitor, and that monitor, it will have to log some data, and it has to parse some JSON files. So the log library, the JSON library, they're this program's direct dependencies. And then those libraries, log and JSON, they also depend on the library for formatting. So this format library, it's a transitive dependency of the monitoring application. So the question now is really, what is dependency management? And for this, I want to reference the Software Engineering at Google book, the chapter written by Titus Winters, where he says, the trick is how to manage a network of dependencies, which we saw, and their changes over time. Because over a long enough period, all the nodes in that dependency network, they will have new versions. And some of those versions or updates will be important. So that brings us to the question, how do you convey information about what updates are important for us? And for this, we do have semantic versioning. Probably you're familiar with the concept, but because it's so important, I quickly want to go into it. So this is the versioning scheme used by many open source libraries. And it reads, we propose a simple set of rules and requirements that dictate how version numbers are assigned and incremented. You first need to declare a public API. And once you identify your public API, you then communicate changes to it with specific increments to your version number. So in general, it has this format. It's 3 versions, x.y.z. And these version numbers are the way that they change, which convey the meaning about the underlying code. So when you make changes to the patch version, that means you're making bug fixes. If you change the minor version, that means you're making backwards compatible changes. So it means that you're adding a function, or you are free to add a function, for example. And only if you increase the major version, then you can make backwards incompatible changes, such as removing functionality. And so this is basically a contract between the library author and the library user, because with this contract comes a user expectation, and this expectation is I can update within the same major version this library without needing to make any changes to my own code whatsoever. And for this, it's also too important to think about what is really your public API, because of course it's the functions and the header files, but it could also be the build files or resources, for example, ini files and so on. What Semver doesn't do is it doesn't make any implications about ABI stability, which is important for us in the C++ world. And some of the projects interpret also major version as that doesn't make any. So everything within the major version is ABI compatible. So for example, this is how Qt does it. But some projects also say we only have ABI compatibility within the same patch, within the same minor version. And new minor version might break that compatibility. Okay, so let's go back to our sample and see how, how we can really use new changes. So for example, JSON is making a bug fix release because it had some parsing error. So it increments its version to 1.0.1. Then next, FMT, what did I do? Sorry. Okay, then FMT, it's releasing a new minor version. They added some feature. Log also makes a new minor version and releases 1.1.0. And then finally, also Mon is making some totally unrelated changes, but they're also releasing a new minor version. Another thing which I want to mention before we move on is reproducibility. So reproducibility can be defined as a build is reproducible if given some source code, build environment, and build instruction. Any part can recreate bit by bit identical copies of all the specified artifacts. And this is generally a property that we want in software development. But if we do not provide a consistent build environment, this means if we have over time different versions of dependencies, then we cannot achieve build reproducibility. Or if we cannot reproduce our build environment, then we cannot also not achieve reproducibility of our software. Okay. So this brings us to the question, how do C++ projects manage dependencies today? So we understand that dependency management deals with integrating dependencies, which are evolving over time. And semantic versioning helps with that. So think about maybe the first time you were relying on another project which had a dependency, like how did you provide that dependency? Maybe a system install, or maybe it was somehow provided. So we had the survey here from Meeting C++ and asked the question, how do you handle C++ and dependencies in your project? Unfortunately, the turnover was not so high, so only 113 people answered the survey, but maybe it still gives a good indication. So there's a few options. So sometimes either like the project doesn't care. It doesn't make any assumptions. Or it says it's the user responsibility, so I need these and those dependencies, have them installed, and then you can do the build. That's two possibilities, but that's not the possibilities that we want to look at. So we want to take a look at providing dependencies as system dependencies. We want to take a look at providing them as with source control or as part of the build process, which seem to be the most popular options in the C++ community. And we want to take a look at using a C++ dependency manager for the time, for the task. Okay, so let's imagine our small monitor application. It has a source file, it has a CMake build file. So if we were using system-wide dependencies, maybe with our project we would support a small or provide a small install script which apt-get installs the dependencies or brew installs the dependencies which we need. And it's kind of nice because with brew and apt-get, the dependencies, they will already be compiled, so it's really fast to go ahead and install them. But if we use apt-get, we have the problem we might be stuck to the version that comes with the distribution, so it might be quite old. And with brew, you always get the most recent version that has been integrated into brew. So it's not reproducible, and this is actually what breaks the CI of our open source project all the time, because there's some new dependency updates within brew. Okay, so this is one possibility. The next possibility, as mentioned, is source code based, which is also called vendoring. And the idea here is really that you just put a copy of that dependency inside your source tree. And that doesn't get your dependency built, so you also have to add it to your build script. Of course, that means the dependency has to use the same build system as your own project, because otherwise you cannot easily integrate it. What it also means is that you need to take a look at your transitive dependencies, because you don't know what the log library and the JSON library are doing. And if they are also providing FMT, and if they are providing it at different versions, you already have a problem. Most of the time, this is actually done by, or you see it on a lot of open source projects, by using Git submodules, because then it's easier to just update your dependencies to a new version. But if you decide to do this, especially like if you're doing an application, it's okay. But if you're writing a library, always do that optionally. Let the user be able to turn that off and provide his own dependencies. And basically the same goes if you do this based on the build system. So CMake has some functionality to do that. It's called fetch content. You define fetch content declare, give a URL, and make that content then available. And then CMake builds your dependency as part of the build. You also have to take care of possibly also have to take care of transitive dependencies in that case. And then There's the last option, which is not so popular with C++ developers. Use a dependency manager. And in that case, you don't have to make any changes to your build files. They just stay the way that they were. But additionally, you provide in Conan, it's called a recipe. In this case, it's a Conan file txt, where you declare your dependencies that you need. You could also use vcpkg, which then lets you define a part file, which it states the same, but it's a different syntax, basically. So, yeah, as we said, only a third of the users, they're using C++ dependency managers to write dependencies. But now the question is, why would we actually want to use a dependency manager to manage our dependencies? Are there good reasons for it, really? And this is what I want to talk about in this chapter. So, to make dependency handling easier, most modern programming languages have dependency managers. So we have Python, comes with pip, JavaScript, NPM, Yarn, C# NuGet, Java, Rust Cargo, and for C++ Conan and vcpkg. So what is really the task? Like, where does the dependency manager help us? And the idea is that first it takes a package specification. It then resolves the dependency graph, and we'll take a look at what that does later. And if it can resolve that dependency graph, we get the dependencies. If not, there's an error message. That's simple. So, resolving the dependency graph. First, we have to specify, or each package has to specify in a specification what kind of dependency it needs. And it can just say, okay, I need an exact same version, I need any version, I need at least or at most, or specify some version ranges. But what's really a good strategy to define this? So the naive approach is just we say, oh, we need any version, and we just don't care. So for this, let's look at our example with a monitor, and we have two developers, Susan and Tom. And they're both developers of the monitoring application. So at day X, Susan is using a package manager to install the dependencies. So she ends up with all 1.0. And she realizes, oh, something is off with the JSON parsing. Like, what is wrong there? And she asks her colleague, Tom, can you please go ahead and check? He doesn't have time to do it immediately, and in the meantime, Jason has released the Spec fix. So Tom is going ahead and installing the dependencies, and he ends up with a different setup. And he says, well, everything is fine. This is a problem, obviously. So more dependencies are released, as we discussed earlier in the tree, and also Jason is releasing a new 2.0 version. So Susan, she says, okay, everything is good at Tom's machine. Let's just clean everything up. Let's start from scratch and go ahead and install again. And now she has the problem. She gets the 0.2 version. That might have broken something, and she's complaining like, I reinstalled everything. I can't even, my whole build is broken. So this we can mitigate by saying, okay, we pin to major versions, but we still have the problem of reproducibility. So we see we can't just use any version, but let's go ahead and use pinned version instead. And this might seem like a good idea, but it's not, and I want to show you why. So JSON, it releases its new minor version and depends on format. Then there's a new format release, there's a new log release, and they all pin their versions. So at this point in time, monitor wants to make a new release. So they use the new log version, the bug-fixed JSON version, but now we have a problem. We have a dependency mismatch in our graph. So in order actually to resolve that dependency graph, JSON would have to go ahead, release a new version which also uses that new FMT version, and only then can we get a graph which doesn't have any kinds of conflicts. And imagine we have a very deep dependency graph. And now imagine that there's an update, a very, very crucial bug fix in package A. So how do we propagate this to E? We have to re-release all of the intermediate packages, and that might take some time. So if there's no more maintainer for D, like we cannot release a bug fix for D to get the very important security fix, and we never are able to integrate it into E. So if anyone says that this is a good idea, it's not a good idea, and especially it does not scale. And this is also basically what the add subdirectory approach, the source code-based rendering, is doing, because yeah, we're pinning certain versions. So at scale, it does not work. So then is the question, what can we do instead? So instead, we can use requirements, but then we can derive lock files from them. So same setup as before. And we install mon, or we use the package manager to install mon. And the first thing that it creates is a log file. And the log file, of course, is also different from package manager to package manager, but essentially it captures the exact versions of what a dependency graph has been resolved to. So you get all the new versions, and then after all the new packages make new releases, you again call install, and you just get exact the same dependency versions as on your first install. And then the package manager also provides you to interact basically with the log file. So for example, if there's been a security fix, and you just want to include like all the security fixes which have been released, you could say package manager audit fix, and it will pull the new minor bug fix release version of JSON, but it leaves basically everything else intact. And you can go ahead and just say package manager update. So it will take a look and get all the new update to all the new versions. Yeah. So how do we use dependency management? This is hard enough for this small graph that we saw. But real packages, they have huge graphs. So there's Octoverse, GitHub Octoverse 2020 report, which analyzed dependency, like packages and their dependencies. So it found that the mean number of direct dependencies of a Python package is 6. The mean number of transitive dependencies is 19, which is already quite a bit. But NPM packages, direct, 10 transitive dependencies, indirect, 680 transitive dependencies. You don't want to do that by hand. You need support for that. So dependency managers, they automate this version resolution and package provisioning process for us. And if we adhere to some rules, like using semantic versioning, describing everything correctly, then we can use them really effectively to manage our dependencies. So that brings us now to the question, what challenges are unique to C++ dependency management? And why, when in 2015 I was looking at a solution, there was basically none, while we had pip in 2008 and we had an NPM and NuGet already back in 2010. So what's so complicated about C++ that we didn't have dependency managers at that point? So what we want to do is we go back and look at the task of what this dependency manager is supposed to do. And it dissolves the graph, and then it provides the dependencies. And resolving the graph, it's not different in C++, but actually providing the dependencies, that's very different, or it's somewhat different, or it has its challenges. So let's further look at what does it mean to provide the dependencies. So we go ahead and start, and the dependency manager has to see if there's a binary package available already, which is compatible with what we are needing, basically. If this is the case, this package can be downloaded, and it can be made available to the user. If this is not the case, then the package manager would have to download the sources, it would have to build the package, and then also make that package available to the consumers. So if we take a look at other programming languages, if we have, for example, a JavaScript package, which is basically interpreted code, we don't really have the problem of determining if this package is binary compatible, because it's just source code, it will always be compatible. We can use it, no problem. If we have Python code, often they are also source packages, and then that's also fine. But Python, it has like a source package format, which is an sdist, and it has a binary package format, which is a wheel. So Python communicates the compatibility of a binary package, a wheel, by the name of the wheel. So if that wheel contains only Python source code, it will be a non-any wheel. It cannot just always be downloaded. And then otherwise, compatibility depends on the Python version and also the platform architecture. So the wheel could be named CP39, CP3939, and then win64amd.wheel. And then if you're using Python 3.9 and you're on Windows, that package will be available for you. However, it's not so easy in the C++ case, because a lot more factors play into that determination if we can actually go ahead and use a pre-built package. Then we have the problem of building the package. And it's also not so easy because there's no standard C++ build system. So when you have a package manager, that package manager, it has to go ahead and abstract that build process to invoke the actual build system. So it's also not, it's doable, it's not so easy. And then there's the third point, make the package available. And there's the question, yeah, what is a C++ package? There's no such thing as a C++ package. So let's together take a look at how Conan solved these problems. So the first question is, when is an existing binary package compatible? And it depends. So it depends on the settings, basically, of a package. So which compiler did we use? First, which platform are we on? Which operating system are we on? Which compiler did we use? Which architecture are we supporting? But then it also depends on options. So did we build a static library? Did we build a shared library? And what are its dependencies that we have used? So if we used, for example, FMT 1.0 to link against, that's a totally different package than if we used a newer version of FMT, and these cannot be used interchangeably. So in conjunction with a file which is called a profile, which defines these settings that we are currently building for, Conan can go ahead and compute a hash of these options, settings, and requirements, which is a package ID. If this package ID is identical to one which has already been previously uploaded, it means I can go ahead and take that package, which has already been built, and I don't need to rebuild the whole thing. So Conan has found a way to actually determine when they can reuse a pre-built package, which is good. Okay, so that problem is solved. Then the problem, how do we build? The package manager has to find a way to orchestrate the builds, really. So what Conan did in this case, they provide a build method to the user where they can use some build abstractions. So there's helper classes to invoke CMake builds, there's helper classes to invoke a meson build, but you can go ahead and you can do anything. You could go ahead and invoke your own private build system and later then install that. Awesome. So that it's also possible, it's also doable. Which brings us to the last point. There's no such thing as a C++ package. And if you think about it, so how is it done currently if you're trying to locate another package? There's bcconfig. There's also CMake. They have their own format to do that. They're called CMake config files, but they are written in CMake language, so they are hard for everyone who's not building with CMake to understand and to interpret. So we need another solution. And this is actually something which is currently being worked on. So the Common Package Specification, CPS, is a mechanism for describing useful artifacts of a software package. A CPS file provides a declarative description of a package that is intended to be consumed by other packages that build against that package. So the idea is really to make that information, how to later consume a package, independent of any tooling and to make it declarative. And sample configuration, CPS configuration file could look like this. So there's some information about the name of the package, there's information about the version of the package, and then there's all the information that you need to know when you want to consume a package, which is mainly where do I find the header files, which library do I need to link, do I need to provide some additional defines, and do I also need to link some other libraries transitively. So in our case, we also would have to link the FMT library if we're linking basically our JSON library to monitor. And CMake has added some experimental support to generate the CPS files and to consume the CPS files. And Conan is also on the way to integrating that experimentally. And if that really converges to be a standard, this will be a really, really huge deal for C++, because it would allow you to use or to really separate this process of managing dependencies and building dependencies. Which leaves one last point, which is a bit difficult. So let's put it this way. When I go ahead and say pip install, there will almost always be a precompiled wheel for the package which I want to download, at least for the recent Python versions for the standard platforms. But as we said, there's so much settings which go into this binary compatibility for a C++ package that even if we want, a package registry cannot offer all these different combinations. And for me, that's a real pain point when working with Conan and the Conan Center index, that I think I have a common compiler and use some common packages, but then it complains, I have nothing pre-built for you. Please build this and this and this and this. But I don't know if this is a problem that we can solve. So let's summarize. The first point. Dependencies, they're software components that are developed independently from our project. And there's a cost of using these dependencies. And dependency management is the art of orchestrating these dependencies over time. In C++, most package maintainers, they use or they integrate packages either manually, and only a third of them rely on dependency managers. But if we use a dependency manager, we don't have that task of manually retrieving and updating the dependencies, and thus it can save us a lot of time. C++, it lacks a common package description, it lacks common build tooling, and it's non-trivial to describe package compatibilities. But we can overcome those problems and really let's support the CPS activities that are ongoing by trying the experimental features and giving feedback to those developing it, so we can really push for this to become a de facto to become a standard. So thank you everyone for this talk, and I have some references, but also what I wanted to mention, if any of you are doing presentations, these are 2 podcasts which I listen to, which talk about, basically how to present science, and I highly recommend those. So thank you, everyone.
Thank you for the talk. Do you have perhaps experience or knowledge how easy it is or how possible it is to set up a private first-party repository with these package management tools?
Mm-hmm. So with Conan, it's easy if you have Artifactory. So if you purchase JFrog Artifactory, you can create these Conan registries, and you can use that to use your own dependencies and upload the packages, upload binary packages, and so on.
So I have a question from the online audience.
Yeah.
In slide 57, you mentioned about Python dependency management. I didn't get that term correctly. Could you please describe again how it differs?
One more. So, can you say it again?
You mentioned about Python dependency management. I didn't get that term correctly. Could you please describe again how it differs?
Yeah, so with Python, you can write a requirements.txt file where you put your dependencies, and you run then pip install -r requirements.txt, and that will also have to go ahead and see where's the dependencies and what do you need, what are the newest versions, and then basically it applies the same overall structure. Like it has to find a wheel file which is working for you and specific for your platform, and then download these dependencies and provide them for you.
Thank you.
Yeah, question about ABI compatibility. So if I have some dependencies, and if I turn on certain build flags for the dependencies, will they like always affect the package ID, or like do I risk if I put like the build env stuff that now it will pull something that has the same settings, but
if you have flags that or influence the package ID, it makes a lot of sense to really glob them, let's say, in a setting which you can then explicitly set in your profiles. And in these profiles, you can set the settings, but you can also set, for example, some flags. So you can have a flag section. You just have to make sure then that these flags you also reflect somehow in a subsetting, for example, of the compiler. And then you will make sure that the whole tree is basically built with the same set of settings when you use that profile.
Right, but like if there's some specific build flag that's not like supported out of the box in the settings for the packages I'm trying to build against, I can set them in like the build env section. Do you know if that affects the package ID? Because if I do that and I build everything, then they will go into the build. But if it finds something that has been built already with the same settings, but with different build env, then that would not be ABI compatible. Do you know if it do I risk that it reuses the one that uses the same settings but different build envs? Do you know?
Yeah, it depends how you. I cannot like this answer your question. I think you do, but you have to make sure that. I mean, you can do it via an option, for example. If it's like a flag for that specific package, you can put that in an option of the recipe, and then you have different options if you use that flag or not, and then you will get different package IDs.
Okay, thanks.
Okay.
Another online question. What are your thoughts on this, on CPM, the CMake package manager?
I haven't used it personally. I think it can be okay. I can't really comment on it. It will be operating on repository, on build system level. And for us, it was always a priority to have a package manager which can operate on binary level. So we save build times and we can actually reuse pre-built binaries. So that was our main focus, and this is why I can make a comment on CPM.
Thank you.
Yeah, thanks for the talk. You mentioned vcpkg, and I was under the impression that vcpkg gained a lot of traction in the last few years, and they were winning the competition. Could you please elaborate a little bit on why you chose Conan over vcpkg?
So again, vcpkg also does not manage binary dependencies. For us, this was a huge it was an important factor, because we just said we have so many so many dependencies in our builds that taking in these dependencies and not having to rebuild them was a higher priority, basically. And if you don't have that priority, you can go ahead and use vcpkg. I think it's a wonderful choice if you're maybe a smaller company which doesn't have or dedicates so much into build infrastructure. You don't have to set up a build, like a Artifactory server where you manage those binary dependencies, like the binary packages. So I guess it's a really good way to do it.
Hi, thank you for your talk. One question: how do you manage the versioning of the dependency manager itself?
That's a good question. Actually, we don't do it. You can make requirements with Conan. I can speak for Conan. For Conan, you can manage requirements in your settings file. So you can say everyone needs to use that specific version of Conan. So that's a thing you can do. But they really try to be compatible, at least in the output. So I don't know if this is 100% a necessity, but yes, if you say reproducible builds, put in that also pin the version of your dependency manager, and then you should be safe.
Hi, thank you for your talk. How do you version your profiles?
We have them in a Git repository, and you can go ahead and do a Conan config install, or every user is orchestrated to do a Conan config install so that every user has the same profiles on their machines.
Thank you for your talk. I have a question regarding the registries.
Mm-hmm.
So if I have a private registry
Mm-hmm.
and I can push the versions there, what about local development? Do I always have to go through the registry? Or I can do,
No.
if I have two repositories, which one depend on each other, for example?
Yeah, you can work with a private cache. So you can also locally build packages on your PC and they will go into the local registry. And you can then also consume packages from the local registry. Or from the local cache on your machine. So you can really use that to co-develop. And Conan also has some features like workspaces, which don't require you to necessarily publish or export a package to the cache before you can use it. So you can have some kind of co-development.
But for example, if I have two repositories locally on my machine, and I do change in A, then I need to call Conan to build A, and only then I can use it in B.
You can do it like this, but as I said, Conan has this workspaces feature, which allows you to basically abstract away and work on both repositories at the same time.
Cool, thank you. It's called workspaces, right?
Yeah, I think so.
Okay, cool, thank you.
Yeah, another thing about ABI. So what I just started doing is first I do Conan install of all my dependencies, and that creates a CMake toolchain file. And then I use that in my CMake project. Is that a good way of making sure that I'm ABI compatible with the way I built my dependencies, or like do you have some advice on making sure? So when all the Conan things are built together, so that's easy. But I want to make sure that my project is also ABI compatible. If you have any advice on that.
Yeah, so I don't know if there's how to do it with the open source Conan, but what we do is that we use a generator to generate basically a top-level CMake file or a toolchain file, which we then use to do the whole build. So it kind of sounds like your approach. So we generate a tool. Okay, yeah. So actually, yeah, we do it the exact same way.
Another online question. Automating retrieval of dependencies is not so desirable in view of security glitches, like the one recently seen in NPM. Do you have a recommendation how to control that?
Well, when you're using Lockfiles, you don't automatically update the dependencies. You update them on demand, basically. You can automate this process, for example, by making pull requests regularly on your repository that's updating those dependencies. But yeah, with the Lockfile, you're stuck, or you fix yourself to specific versions. And then you can use, I think Conan doesn't have it, but NPM has this audit fix where you can really go ahead if something is flagged as a security fix, that you can check if you have any affected packages in your log files, and then you can go ahead and update those.
Hi, Kerstin.
Yeah.
At my last employer, I had the honor to try to introduce Conan for our third-party dependencies, especially to create SBOMs, and that worked fine. But something I noticed, we had some quite old versions of the third-party dependencies that were not online on the public open source Conan repository, although they were mostly all open source. So I had to write them myself. We had our own repository for all this stuff. And then after a while, I noticed, okay, we have a combinatorial explosion, because for every little detail, we had to build our own package, and because otherwise, with several different compiling options, those libraries don't work well together. Is there some other solution than what I just did to rebuild the world, or is that just how it is?
I think this is how it is, and I can just say what we did. We completely rewrote all our recipes, or we didn't use any Conan Center recipes in-house because we rewrote them all. We also didn't want to fetch dependencies from, let's say, a GitHub repo. We mirrored the repos, then we can use these mirrored repos to actually build. And when you do this, you can also make some simplifications because the Conan Center Index recipes, they need to cater to a lot of users. They basically make options for all the build options that you, for example, have with the library like OpenCV, which are a ton, but maybe in your internal use case, you don't need all of that variety. So if you have internal recipes, you can greatly simplify them and keep them basically in-house.
Okay. Thank you for the talk. I'd like to ask, we were able to successfully migrate to Conan 2 because it was a really big change in community and recipes and formats, and the compatibility between versions was, I don't know, probably for a few years only. So how did you manage to do it?
Yeah, so actually it's not so easy also because of changes which they did of how so when you do cross-compile builds, for example, they had a totally different concept of you have a build profile and a host profile. So before they just said, okay, you have a build compiler and you have a architecture compiler. And they totally relaxed that system, so you have a build profile and you have a host profile. So when you build, you build everything in the host context, and then you move to the build context if you need to build some tools which you need to use during the compilation process. And yeah, there were so many glitches, but because internally also we have our dependencies in kind of like a internal Conan Center index, it was quite easy to actually just rebuild everything from source for that. So it actually works, or it actually worked, although it was a little bit of work. Sure. No, it's fine.
Not everything is managed by Conan. For example, if you have code generation and use Jinja templating, you need Python and Jinja installed, which is not managed by Conan. What are your thoughts on these 10% cases which are not covered by Conan?
I mean, you can still orchestrate the installation of Conan and then also Ninja to generate, or if you, I guess this question somehow talks about that you can have your own generators which can use these Ninja templates. So yeah, also fix the versions which you want to use, and then have your reproducible builds also in sense of the dependency management.
Thank you for the tip with workspaces. I've just looked at the documentation, and that reminds me another question. With Conan, you always need to use Conan CLI to build something, to do something first, right? How does it work in your experience with people who just get used to use IDE and they just want to press build button?
So we really divide the provisioning of the packages from the development of the packages. So the way we did it, we have a really simple process that first on CLI you just say Conan install, and you get then afterwards your Visual Studio solution, and you just go ahead and work with that Visual Studio solution, and then you have your development environment. But then later on, these package or the software is then packaged also with Conan. So you can kind of coexist these two ways, so that the developers, they can work the way that they're used to, but the packaging is automated then by CI.
Thank you.
So I kind of have a question about your code organization, because from what you're talking about, it seems kind of like you might have kind of more of a do you use Conan to manage internal dependencies? Like if I work on this core library and you work on this kind of super application, do you use it for that, or do you only use it for external libraries?
Yeah, we mainly use it for external libraries or anything which has like fixed release cycles where you can really depend on releases. The co-development is really, you do have the workspaces, but it's not so as intuitive as it can be. So it's really, really good where you don't change your dependencies that often, or you pull it from outside, like the third parties, but internally it could be improved.
So how do you do it internally? Do you have like a monorepo or?
Yeah, in the particular use case where we use Conan, we do have a monorepo.
Right. Thank you very much. We're out of time. Thank you again.